at the part where we're going to design, we're going to design counters for a certain count sequence. And our first count sequence is to go from 0 to 14. So that 14 is not any bigger than 15, so we only need one counter, because a 4-bit counter goes from 0 to 15. If we need more than that, we need two 4-bit counters. What we want to look at are the binary values of our beginning and our ending, and we need to think about in between, and you'll see what I mean by that when we get to one that needs it. So we start with 0, so that has Q0, Q1, Q2, Q3, all 0, and we end with 14. So let's think about how to make 14. Oh, that's right. Y'all are 2742, so yeah, you know binary numbers. Okay, 1, 2, 4, and 8. So 14 is 8 plus 4 is 12 plus 2 is 14. So 1110. So when we get a 1110, that means that that's 14, and it would be time to start a new count. So we would have our counter, and it has an enable, and we'll have D0, D1, D2, D3, and we're starting at 0, so we'll just put a 0 on each of these, and we have a load, and we have a clock, and we have our output Q0, Q1, Q2, Q3. Now, if you wanted to be super safe, then you could have this Okay, so what I just did there is I made sure that I had 1110 by putting this NOT gate on Q0. So this makes sure that Q0 is 0. But I don't actually need that, and I think the directions say to use as few let's see, the directions. Using only simple gates. Okay, it doesn't say, oh, but on your homework it says use as few gates and copies of C as possible. So you want to try to be efficient in your homework assignment, and so we don't actually need this NOT gate, because if we start at 0, the very first time we're going to get to where the other 3 are 1 is going to be at the right time. We don't have to specify that the first one is 0, because that will be the first time that all 3 of these are 1. So we just need that. Okay, and then the next one was 3, 4 to 12 to 3. 3, 4, up to 12, and then back to 3. Okay, so 3 looks like 0, 0, 1, 1, and 12 looks like 1, 1, 0, 0. That is not a rectangle. That is also not a rectangle. That is a rectangle. Okay, so we know that we need to load 1. It's always weird to me because it seems like it's upside down. We would write 3 as 0, 0, 1, 1, but when I put it in as I'm loading it, it's 1, 1, 0, 0 because the lowest bits are at the top. And to me, it looks upside down. And then I know that I need both Q2 and Q3 to be 1 to load the next time. And what I need to do is ask myself, is 12 going to be the first time that both of these are 1? And the answer is yes, because if both of these are 1, that means that we've got an 8 here and a 4 here, and that gives us 12. And there's no number smaller than 12 that has both 8 and 4 added together in it. So I don't need to do anything with the others. So this would be it for that particular one. Okay, and then the next one is 5 to 15, and then to 0, 1, 5. Okay, all right. So this one is going to be a little bit different, because notice that we wrap around and we get some numbers smaller than 5 before we go back to 5. So let's look at our numbers, our binary numbers for 5 and 15. So 5 is 1. That's not right. 5 is 0, 1, 0, 1. And 15 is 1, 1, 1, 1. Oh, but I don't want to detect 15. I want to detect 1. Because I go from 5, and notice when you count, when a 4-bit counter counts, the next thing it counts after 15 is 0. I don't have to tell it to go to 0, it'll do that on its own. So if I just said start at 5 and keep counting, it would go up to 15 and then 0, 1, 2, 3, 4, 5, and so forth. But I need it to stop at 1, so I need it to detect a 1. But I want to be careful with that. So this is the number I'm detecting, and that's the number I'm loading. I was loading 5, which is, so this is Q3, Q2, Q1, Q0. So 1 here, and 0 here and here. And I want to detect a 1. Well, I'm going to go back to that page that I made where I have all the binary numbers listed. Now I can't just, notice I can't just say, oh, let me this. I can't just say, let me just put the 1 in here, because that would detect it on the very first try, because for the number 5, Q0 is 1. So if I did it just like this, I would get 5, 5, 5, 5, because every time it would load. So that's not gonna work. So instead, if we look at these numbers, what's the smallest number of gates and inputs we could use to detect when we get a 1 and it is not used on any of these other numbers? So for instance, if I said, so 1 looks like 0, 0, 0, 1. We already know we can't use just the 1 because the numbers 5, 7, 9, 11, 13, 15, they all have a 1 there. I can't use just the 0 and 1 because if you look, 9 has a 0, 1, 13 has a 0, 1. Could I use just this 0, 1? And the answer is no, because 9 has that. Could I use this 0, 1? Let's see, starting at 5. No, because 5 itself has that 0, 1. So it looks like I'm going to need at least 3 of these. What if I had those 2? So 0, 0, and the 1. So any of the numbers in this part or this part, do any of those numbers other than 1 have 0, Q3, 0, Q2, and 1, Q1? It doesn't look like it. It looks like another way I could have done this. So I could AND together. So on my output from my counter, I can AND together Q1 and the NOT of Q2 and Q3 and put that into the load. It looks like another way that I could do it. Nope, I was going to say the first 3 zeros, no, but that would detect it on 0. Now, I could, if I wanted to be safe, I could put the NOT on that one as well, but I don't need that. So this is the final answer. Let me get to it. I don't know what page it was on. Did anyone happen to notice what page I started this one? Where am I starting counting at? 5? Okay, I'll just start over. Oh no, this is it. So I said that I wanted to detect the AND of Q0 and not Q2 and Q3. And that should do it.
Zero, zero, and then the 1 for Q0. Like, how did you do that?
How did I do that? Okay, so I'm looking at, I want to detect the number 1 right here. And so I want, this is Q3, Q2, Q1, and Q0. And when I get to the number 1, that means Q0 is 1, and Q3 and Q2 are both 0, so their knots are both 1. So all of these are 1, and I want the and of those. And I'm saying if I start counting at 5, and I could be wrong, I'm looking at the answers right now. If I start counting at 5, and then I go all the way through 15 and back to 0 and then to 1, that the first time I encounter having Q3 and Q2 0 and Q0 1 is at the number 1, and so that will detect that.
Okay, thank you.
Okay, because in order for if Q3 and Q2 are 0, so Q3 and Q2 are 0, that means that I have to be a number that is 3 or less, because if I'm bigger than 3, then one of these is going to be 1. So I have to be a number that's 3 or less, and if I'm 3 or less, that means I'm 0, 1, 2, or 3, and the only ones of those where Q0 is 1, and I get to 1 before I get to 3. So I'm just saving myself one input on an AND gate by not including a not right here.
What about the skip when it skips from 1 to 5?
That's what this does. So right here, okay, right here, when my number is 1, this and is true for the first time. This is 1. That's a load, so it's going to load what I have out here, which is 5. So my next value that's going to come out will be 5.
Okay, thank you.
Okay, are you sure that makes sense? Okay, because the whole point of what we're doing on these counters is we're putting our start value, like when we skip to something, that value is what we're putting here on our load. And so what we're doing, what our goal is to detect when we want to do that skip. And when we detect that, then we're going to load the next number on the load over here. So the load includes, so if I'm going, if I wanted to go 7, 8, 9, 10, 7, 8, 9, 10, I want to detect a 10 and load a 7. So I would have a 7 here, right there, and then I'd want to detect a 10. The easiest way to detect a 10 is 1, 0, 1, 0, and to make sure that I get it right would be not this would be 1, 0, 1, 0. So I have knots with the zeros and ones there. Put that in an AND gate and put that into the load. and this will definitely work. I don't know if it's the most efficient one. I don't know if I need to detect all 4 of these bits or not. I might be able to get away with not detecting them all. Let's see, just for fun, I'll go ahead and do it. So I'm starting at 7, and then the next number after 7 is 8, and then 9, and then 10. So if I'm starting with 7, and I want to use the minimum I can to detect when I get to 10, I could just detect these 2 right here. Because that's not 10. 10 is 1 0 1 0. So I could detect if any 2 of these that don't show up in a smaller a number in between. So like for instance, if I look for the first time I get both a 1 and a 0, that would do it. Or the first time I get 0 1 right here, that would also do it. So those would just be shorter ways to get to it. Okay, now I'm going to stop this and restart it and then do the last few.